It's time for another amazing chemistry video with Mr. Stapleton, proudly sponsored by Farming Union Nice Coffee.
Hi guys, welcome to next video. This one's going to be all about some stoichiometry calculations. So what I'm going to be talking about today is firstly the mole and what that means, and then how we just do some basic calculations. So what I'm going to be talking about a lot today is something called Avogadro's constant, which is 6.02 by 10 to the 23. Okay, it's really important that you remember that number. So what we need to work out or get an understanding of first is what exactly a mole is. Okay, so what I'm going to be doing is I'm going to be using the molecule sulfuric acid. Okay, so I'm just going to create the molecule here because I really want to explain it for you. Alright, so here's our molecule. Okay, if we draw in our bonds, we've got double bond to oxygen, single bond there. Alright, and we've got, that's the shape of our sulfur dioxide molecule. Okay, so that is one entire molecule. Okay, that's one molecule of sulfuric acid. If we're talking about 1 mole, okay, of sulfuric acid, what that means is that we have, using Avogadro's constant, 6.02 times 10 to the 23 particles. Okay, so 1 mole of sulfuric acid is 6.02 times 10 to the 23 particles. But if you have a look, sulfuric acid is made up of a number of different things. Okay, so if we wanted to talk about, I'm just going to move these out of the way, if we wanted to talk about how many particles or how many atoms we have, right, within 1 mole of sulfuric acid, if we break apart all of the atoms that we've got in there, we know that sulfuric acid is H2, alright, so there's 2 hydrogens, it's S, 1 sulfur, and 4 oxygens, okay? So what that means is in 1 mole of sulfuric acid, we've actually got 2 by 6.02 by 10 to the 23 atoms of hydrogen, okay? Because there's 2 hydrogen atoms in every 1 mole, over 1 molecule of sulfuric acid. So it makes sense that there's double that number of atoms. In the formula, there's only 1 sulfur, so there's actually 6.02 times 10 to the 23 atoms of sulfur. And, hopefully you worked it out, there's 4 by 6.02 times 10 to the 23 atoms of oxygen. Okay? So 1 mole, one molecule is made up of 2 hydrogens, 1 sulfur, 4 oxygens. 1 mole of sulfuric acid is made up of 6.02 times 10 to the 23 molecules or particles of sulfuric acid. Alright? But within that 6.02 by 10 to the 23 molecules, so all those millions and trillions of them, we've got twice as many hydrogen atoms, right? Same number of sulfur atoms, and 4 times the number of oxygen atoms. And that's really important to remember when we're starting to look at doing some calculations, that when you're looking at concentration, particularly when we're doing concentration calculations involving acids, that you may have a concentration of the acid, and you may need to remember that there's actually double the concentration of hydrogen ions in there, okay? Such as in sulfuric acid, where it's a diprotic acid. So hopefully I should be able to show you some more of those a bit later. So what I want to do is introduce you to a couple of the formulas that you need to use, okay? So I'm just going to leave in mind Avogadro's constant all the way up there and introduce you to the first one. All right, this one here. So these triangles, I'm going to show you 2 of them. These triangles, there is no substitute for being able to just remember these. There's no substitute for being able to do the formulas really quickly, but if you can remember these triangles, you'll be able to do any of the calculations, okay? So what we've got here is an M, a small m, an N, and a big M, okay? What they refer to are 3 different things. So the M refers to the mass, okay? And the units of that are grams, okay? The N refers to the number of moles, okay? And the units for that is MOL. Big M stands for molar mass, okay? And the units for that are, hopefully you can work it out, grams per mole, okay? So, what I'm going to show you firstly, because in order to do all these calculations, you need to be able to calculate the molar mass, this one here. So I'm actually going to focus on this first and show you how we calculate the molar mass of anything using the periodic table. Okay, so what I'm going to do is I'm going to go back to our sulfuric acid molecule. Okay, so I'm just going to move that up there for a minute. I'm going to bring our sulfuric acid molecule over again, so it's H2SO4. Okay, so 4 oxygens, so it's H2SO4, sulfuric acid. Now, if you look up on the periodic table, what you'll actually find are these. Okay, so we've got hydrogen, we've got sulfur, and we've got oxygen. So we've got the atomic number, which is the smaller one on the periodic table, okay? But then we've got the molar mass, and the molar mass is actually this number, which is always the bigger of the two numbers on there. So for hydrogen, our molar mass is 1.008, for sulfur 32.066, and for oxygen 15.999. Okay? So what we do is we need to calculate the molar mass. We just work out how many of each atom we have. So there's 2 hydrogens, so the molar mass is 2 by 1.008. Okay? Our sulfur is 1 by 32.066, and our oxygen is 4 lots of 15.999. So all you've got to do anytime you're trying to calculate the molar mass of something is work out how many atoms of each you've got in there, okay, and then multiply your molar mass you get off the periodic table, okay, by however many atoms you've got. So if you put this in your calculator for sulfuric acid, you'll come up with an answer of 98.078 grams per mole. That's our molar mass. Now, it's really, really important that you do not round these off in any way when you're using them in your calculations, okay? Use the values that are on the periodic table. Don't round oxygen off to 16, okay? Don't round hydrogen off to 1, okay? Use the value that is on the periodic table, all right? And actually just add them up and you'll be able to get your molar mass, okay? So hopefully that's pretty straightforward. I suggest you go off and try some, all right? You might want to try some like sodium carbonate, Na2CO3, that's one we use quite a lot. You might want to go over and do some other ones, maybe work out glucose, C6H12O6, alright. Try and work those out, see what values you get. From memory, you should get about 106 for sodium carbonate, you should get about 180 for glucose. So try those out, use a periodic table, see how you go. Once you've actually gone through and you've been able to work out the molar mass of your sample, ready to start doing some of your basic stoichiometry calculations and working out how many moles you have within a certain amount. So the first practical we're going to do involves making a standard solution, okay? And we're actually going to make a standard solution of sodium carbonate, okay? So what we'll do is we work out from the periodic table what it is. So our molar mass from the periodic table is 106.005. Okay, make sure you can work that out. Okay, if you can't, go back, just skip back through the video, have a look how I did the one for sulfuric acid, see if you can get it. All right, so let's say that we are taking, I don't know, let's do 1.63 grams of sodium carbonate. Okay, and so what we're doing is we measure that out accurately on our balance, right? 1.63 grams of sodium carbonate. And what we want to do is we want to work out how many moles that is actually that we've done. So using our little triangle here, number of moles, all right, this is the one we're using. So we've got little m on top, which is our mass, and we've got big M on the bottom. So it's mass divided by molar mass. Okay, so we put our mass in here, 1.63. We put our molar mass in here, 106.005. And we work out our value. So this value here, 1.63 divided by 106.005, don't round it off, is 0.0154 moles. Now I'm going to get to significant figures a little bit later, but hopefully you can see what I've done here is I've got 3 significant figures for sodium carbonate and I've done 3 significant figures here, and we'll talk about that a little bit later. But that's the number of moles of sodium carbonate that we've got. So you can see that when we're doing our calculations in the lab, we generally work with small amounts. We don't have full moles, Okay, we don't have 1 mole because that's a lot of particles, that's a lot of stuff. All right, we would have to take 106 grams of sodium carbonate to get 1 mole, and that's way more than we need. So let's say that we've got this sodium carbonate, okay, and we've taken 1.63 grams of it, and we're going to make it up in a 200 milliliter volumetric flask. Okay. What we can now do is work out the concentration of our solution that we've made, and to do that we introduce our second diagram, okay, our second triangle. Here we've got N, a C and a V. Now N is exactly the same as up here, it's number of moles. Our C is our concentration, and the units for that are moles per litre. V is our volume, and this is the one where people really get stumped sometimes, okay? The units are in litres, okay? Because your concentration's in moles per litres, you need your volume in litres. A lot of people forget to do those conversions from millilitres to litres because all the stoichiometry titrations we do involve calculations using millilitres, but they forget to divide it by 1,000 to convert it to litres, so it's really important you do that. So, using our second triangle here, okay, if we want to work out concentration, C, it's N over V, okay, number of moles over volume. So we know from what we just did before that for our number of moles we had 0.0154. Now, when you're doing that, I've just taken the number we had from before, but make sure you leave it on your calculator and use that as you go through so you don't get rounding errors in your final answer. And our volume is 200 mils, okay? So it's 200, but you want to divide that by 1,000 to get it into litres. Remember, that's the bit most people fall down in, so make sure you do it, okay? So if we do that divided by 0.2, which is what it is, okay, so that's 200 divided by 1,000, we get a value of 0.0769 moles per litre as our concentration, okay? So all we did to begin with was weigh out 1.63 grams of sodium carbonate. We calculated our molar mass off the periodic table, just adding together all the values, right? 2 lots of sodium, 1 carbon, 3 oxygens, adding all those together. We calculated our number of moles by doing the mass divided by the molar mass. So it was 1.63 divided by 106.005. That gave us our number of moles. What we then did was use our second triangle, concentration equals number of moles over volume, to get 0.0154 divided by the volume, which we put into litres, 200 over 1,000, and we got a concentration of 0.0769 moles per litre. Okay, and that's really that's how you use these two triangles. What I suggest you do is you go through and you practice using them, okay, and you can use them to get any sort of formula, okay. So using this first one, you can get 3 different formulas out of it. You can get mass equals number of moles times molar mass, all right, M, N, M. You can get number of moles equals mass over molar mass, okay, and you can get molar mass equals mass divided by number of moles. But remember, for that one, you usually just calculate it off the periodic table, so you don't really need it. With the second one, you can get number of moles equals concentration times volume. So hopefully you can see how you actually can start to substitute around when you've got 2 values for N. That's a little bit later on. Okay, you can get concentration equals number of moles over volume, okay, like that. And you can also get volume equals number of moles divided by concentration, okay. So 6 individual equations that you can use, and rather than remembering 6 of them, you just remember 2 triangles that look like this, okay? And the way I tend to remind people to remember is number of moles is birds over mountains. So if you've ever remembered people who draw birds looking like that, if you can't really draw like me, okay? So birds over mountains, okay? And then the other one you just remember, if you remember concentration is moles per litre, you can remember concentration is moles per litre, and you can get that value as well. So learn those 2 triangles, no substitute for it, okay? Need any help? Just ask me. Hope it's good. Thanks, guys.